we're going to continue talking about oxidation states. And we're going to find some generalizations that in how we can figure out if there is it has been an oxidation or a reduction without even doing oxidation numbers. So I'm going to draw the series that we studied before. So here we did the math, and the oxidation state here was -4. And we'll learn how to do that. So just so you remember, we assigned electrons to the more electronegative atoms. So here, all 8 electrons are assigned to carbon, and the math is 4 minus 8 equals -4. That's what we did. So just drawing the other compounds, I was replacing, see if I replace one hydrogen by an oxygen, then the math here would be this 2 going to oxygen, this 2 to carbon, this 2 to carbon, also to carbon, and we say here 4 minus 6 is -2. Then we're going to do one more. Let's say, now we have this. Now we're changing the oxidation state. Let's see how that changed. The 4 electrons go to oxygen, this 2 to carbon, this 2 to carbon. And in doing the math, we do 4 minus 4, that's 0. Let's do one more. And let's just throw the carbon, so let's keep track of the atoms. And again, all these electrons are going to oxygen. This also go to oxygen, but this 2 go to carbon. So math here is going to be 4 minus only this 2. So this is a +2 oxidation state. And carbon dioxide, we also did that one. So the 4 electrons here go to oxygen, same here. And so carbon doesn't have any electrons assigned, so we say 4 minus 0 is +4. And we said now, analyzing the series, that if we go from, say, left to right, oxidation numbers are increasing. So this is oxidation from left to right. Notice the numbers. But if I go from here, +4 over there, this is a reduction. Oxidation numbers are decreasing. But now I want you to notice something. When we go from here to here, which is an oxidation, here we had 4 bonds to hydrogen. But here, I have 1 less bond to hydrogens. I have only 3, and 1 more bond to oxygen. And moving on, so less bonds to carbon, hydrogen, and 1 bond to oxygen. Moving on to the right, which is the oxidation according to those numbers, I notice that I only have 2 bonds to hydrogen. So 1 less bond to hydrogen compared to this. But 2 bonds to oxygen. And following that progression, here this carbon has 1 bond to hydrogen and 1, 2, 3 bonds to oxygen. So we can conclude here, and here we have 4 bonds to oxygen. We can conclude then that in oxidation, as we get oxidized this carbon, there will be less in oxidation. Say, as it oxidizes, less we can count the bonds to hydrogen, and when it oxidizes, we find less bonds to hydrogen, and we increase the bonds to oxygen. This is regarding oxidation. But when you go to reduction, the opposite happens. So we see here 4 bonds to oxygen, but here I only have 3 bonds to oxygen and 1 to hydrogen. And the opposite is true. So in reduction, we see that as it's reducing, you decrease the number of bonds to oxygen, and you will increase the number of bonds to hydrogen. So here, by inspection, we can say then, because here the number of bonds to oxygen had increased and the bonds to hydrogen had decreased, then we can say that this process is an oxidation. So more bonds to oxygen is more oxidized, or more bonds to hydrogen is more reduced. And we're gonna study now reactions that involve both oxidation and reductions.